Hello all, this is Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about image segmentation in image restoration and segmentation. Okay. First of all, what do you mean by image segmentation? Here, the segmentation, it divides an image into its constituent regions or objects. Okay, segmentation of images is a difficult task in image processing, still under research. Segmentation allows to extract objects in images. Here, we consider the segmentation is unsupervised learning. Model-based object extraction, example, a template matching. It is a supervised learning here. Okay, why do we need segmentation? After a successful segmenting of the image, the continuous of objects, it can be extracted using edge detection and or the border using the following techniques. The shape of objects can be described based on the shape, texture and color. Objects can be identified. Image segmentation techniques are extensively used in similarity searches. Okay, example, in segmentation algorithms, it is based on one of the two basic properties of color, gray values are texture, discontinuity and similarity. First category is to partition an image into an abrupt changes in intensity such as edges in an image. Second category are based on partitioning an image into regions that are similar according to a predefined criteria. Histogram thresholding approach falls under this category. Okay, in domain spaces we have spatial domain, row column space and histogram spaces, color spaces, texture space, other complex feature space. Clustering in this color space, we have the each image point is mapped to a point in a color space, like color of ij is equal to r of ij, g of ij and b of ij. Here r is red, j is green and b is blue. It is many to one mapping. The points in the color space are grouped to clusters. The clusters are then mapped back to the regions in the image. Example, we have original pictures, segmented pictures, and we have first picture is a flower, second picture is a house. We have original picture in the left side and the segmented picture in the right side. See the difference. Okay, displaying objects in the segmented image. The objects, it can be distinguished by assigning an arbitrary pixel value or averaging pixel values to the pixels belonging to the same clusters. We know that. By segmenting with the help of thresholding, suppose that the gray level histogram corresponds to an image f of xy composed of dark objects on the light background in such a way that object and background pixels have gray levels grouped into two dominant modes. One obvious way to extract the objects from the background is to select a threshold t that separates these models. Then any point xy for which f of xy less than t is called object points, otherwise the point is called a background point. See the grayscale image example, image of a fingerprint with a light background. For fingerprint histogram, we have segmented image. After segmentation, see the MATLAB coding for histograms of images can be constructed using this imhist command. Imhist is image histogram. Previously we have image, fingerprint image. No, after that it will be converted into histogram with the help of this MATLAB code. We have example MATLAB code for histogram construction here. See here, I equal to imread, p out, tiff. They are using tiff file for more enhancement. And here we have ROI color. It returns a region of interest. ROI selected as those pixels in that match the values in the gray level interval. And we have BW is the binary image with ones where the values of R match the values of the interval. See here, all pixels in 110 to 110, 255 will be 1 and white, and the rest is 0, which is black. And also we have thresholding with bimodal histogram. First, basic global thresholding. Select an initial estimate for t, segment the image using t and compute the average gray values with mean 1 and mean 2 for pixels in the regions of G1 and G2. And the fourth one is about compute a new threshold value t equal to 1 by 2 mean 1 plus mean 2. After that, in the last step, repeat steps 2 through 4 until the difference in t and the successive iterations is smaller than a predefined t0. Here we have to consider the predefined parameters based on the applications that we want. See the grayscale image of a bimodal, images of a rice with black background, and segmented image histogram of rice and image after segmentation. Black background and their image is shown in white. Rice is shown as white with black background. And here we are adapting a basic adaptive thresholding technique. Here images having uneven illumination makes it difficult to segment using histogram. This approach is to divide the original image into sub-images and use the thresholding process to each of the sub-images. Here, like bimodal, we have multimodal histogram. If there are 3 or more dominant modes in the image histogram, the histogram has to be partitioned by multiple thresholds. Okay, if t1 less than xy, it is t2. To the other objects class, if f of xy greater than t2, and to the background if f of xy less than or equal to t1, like that we have. Thresholding multimodal histogram, a method is based on discrete curve evolution to find the thresholds in the histogram. The histogram is treated as a polyline and is simplified until a few vertices remain. Thresholds are determined by vertices that are local minima. We consider only local minima, not local maxima. We just consider the local minima in image processing, image restoration and segmentation part. See here the grayscale image multimodal. See the image, original image. See the multimodal histogram. See how it looks like after segmentation. We can get the outline of her face, hat, shadow, like that we have. And color image of bimodal, color image having a bimodal histogram. Here we have histogram of 3 color spaces. And we have the segmented image. Segmented image, here the skin color is shown here. Thank you.